So I gotta make sure we get through what we need to get through. Alright, so we're gonna continue talking about circles. And part of this section deals with the area of a circle, but everybody knows how to find the area of a circle, so we're gonna skip that.
Well, you have Jack or to play music off of video.
Up here, please. Up here, please. Okay, so the first thing we're going to talk about is called a sector of a circle. And a sector of a circle is simply a portion of the circle. What? I changed. Okay, so, excuse me. So, the sector is a portion of a circle. It's an arc that goes from point to point and then to radii, plural of radius. What?
I'm trying to learn.
I don't know. Is it fish or fishes?
I'm trying to learn.
What's the plural of fish? Fish.
Wow.
How do fish stay so thin?
They don't.
Sure they do.
They die.
They eat fish. Anyway. So if I want to find the area of this portion of the circle, so sector AOB, if you think about it, you can figure this out using common sense. Okay? The whole circle. Stop talking. The whole circle, to find the area of the whole circle, we use what formula? What's the area? What's the formula to find the area of a circle? Pi.
Pi times radius squared.
Pi r squared. But we don't want to know the whole circle. We want to know just a portion. So we take that portion and we divide it by the number, we take the measure of the arc. Remember the total circumference of the circle is 360 degrees. So we take the distance of the arc and we divide it by 360. That gives us what portion of the circle is the arc, and then we multiply that by the area of that area of the circle. In other words, if this was 1/4 of the circle, if this were 90 degrees from A to B, then this sector would be 1/4 the area of the entire circle. Okay? Does anybody not understand what I just said? Anybody haven't yet? Luigi? I wonder why that is. Okay, again, if you think about it logically, Luigi, the area of the whole circle can be found by taking the radius pi r squared. But I don't want the area of the whole circle. I just want the area of this portion of it. So what I'm going to do is I find the length, or I'm given the length of the arc, and I divide that by 360 because my whole circle is 360 degrees. And there's a relationship between the length of the arc and the size of the circle that it covers. So in my example, if I said this is 90, if I said this is 90 degrees, then I would do 90 divided by, and then if I tell you that the radius is 5. So if I tell you the radius is 5, we know that the area of the whole circle is 25 pi, right? 5 squared times pi. So the whole thing would be 25 pi. But if this is 90 degrees, what portion of the whole circle think about it for a minute. Sorry. Yes. You would 25 divided by 4 and leave the pi.
Try one.
We are going to try one. We're going to try 2 and that's that. Okay, so we want to know what's the area of this sector, what's the area of this portion of the circle. So what we do is we take the measure of this arc and we divide it by 360, so it's 72 divided by 360 times pi r squared. So we have pi, what's my radius? My radius is 15 squared. And I wouldn't even bother simplifying this. I would type this direct. The question is asking you to put it in terms of pi. So you can actually ignore the pi. So what I would do is I would put in my calculator 72 times 15 squared. 72 times 15 squared, and then divide that by 360. Your answer is 45.
Wait, so we can just take the 72 from over it and use it?
Yeah, you just plug it in your calculator.
But if we divide 72 by 360 and then multiply by 15 squared, we're going to do the same thing?
My only concern with that is if this gives you a long decimal. Now if it's a multiple choice question, you'll be able to match up. Like this happens to be 1/5. This is 0.2. But if it was 0.233794 and you multiplied it by 225, you'd get some answer, and then you find the answer choice which is closest to that one. So yeah, either way, when you're multiplying, order doesn't matter. Okay? All right, simple enough, right?
Yeah.
All right, so let me give you another one, and then you try it. Okay, contrasted with a sector. Remember, when you have a sector, the points on the circle are connected by radii. Here, segment is you're going to take 2 points that are on the circle and simply connect them. So you don't have to go through the center of the circle. That is called a sector. I'm sorry, segment.
All right.
Segment. Yes.
All right, let's
Yes. Okay. All right. In order to find the area of a segment, what you do is you have a sector basically you'll be given something that looks like this. What you're going to do is you're going to create a segment. You're going to connect the 2 points on the circle with radii. And then you're going to calculate the area of this sector. You're then going to create a triangle and calculate the area of the triangle. And then you take the area of the whole sector, you subtract from it the area of the triangle, and what's left over is the segment. So you'll see when we do a problem. But generally speaking, to find the area of this portion of the circle, you're going to create a bigger segment. You're going to create a triangle. You're going to find the area of the whole thing and the area of the triangle, and what's left over is the area of your segment. It's not as difficult as it looks. It's not as difficult as it looks.
Unless you see Jude.
You did to my sleep.
Step number 1 is to find the area of segment ACB. Okay? So to find the segment of ACB, we're going to find the distance from A to B, so it's the measure of AB divided by 360 times pi r squared, just like we just did. You will recall from yesterday's lesson the relationship between an angle and its arc. So if this angle is 60 degrees, how long is this arc? It's also 60 degrees. So we have 60 divided by 360 times pi, and my radius is 18. Pi times 18 squared. And you want to leave this in terms of pi. The question says round your answer to the nearest 10. But this part, we don't want to do anything with pi yet. Okay? So this gives us 54. You plug this into your calculator, and you get 54 pi. Okay, well, we're not done yet. Okay, so step number 2 is to find the area of triangle ABC. Now, what we know about this triangle is that it is an equilateral triangle. So all 3 of these are the same length. Okay? Now, because what we need to create is we need to create an altitude. So we're going to draw an altitude. But what we create when we create the altitude is a 30, 60, 90 right triangle. We cut the altitude, cuts this half of the triangle, this angle in half. So this little angle is 30. This angle is 60, and then this angle is 90. So again, this little angle is 30. Okay, the little angle here is 30. The altitude also cuts this segment in half. So if my entire segment is 18, half my segment is 9. So remember that. From here to here is 9. So when we have a 36, this is one of your special right triangles where we have a ratio between the sides. Remember, the smallest side of a 30, 60, 90 right triangle is x. The middle side is whatever that value is times the square root of 3. And then the hypotenuse is 2 times x. Well, we don't need the hypotenuse here. We need the altitude going from point C to the opposite side. Since the side opposite my 30-degree angle is 9, since x is equal to 9, the measure of this is simply 9 times the square root of 3. Hey, does everybody understand what I just did?
Yes. In a way, somewhat.
Okay, you need to stop bickering and listen. Okay. Because we don't have a right triangle, we can't just use 1/2 base times height. We have to create the height. Now we have a triangle. Here's my height, here's my base. But we need to figure out the length of this height, the dotted line. Because this is a 60-degree angle, this gets cut into a 30-degree angle, and the other one gets cut into a 30-degree angle. So this becomes a 30-degree angle. If this is a 90-degree angle and this is a 30-degree angle, this has to be a 60-degree angle because the angles have to add up to 180. So now I have a 30, 60, 90 right triangle, which is on the reference sheet. It's one of those special right triangles where there's a relationship between the sides. The shortest side, which is opposite the 30-degree angle, has the value of x, whatever that is. The 60-degree angle has a value of whatever the value of x is times the square root of 3. The hypotenuse is 2 times the length of the smallest side. We don't care about the hypotenuse. What we care about is this middle side. We know by cutting this line in half, which we were told is 18, we know that creates this line. Let's call this point R. So from R to B is 9. It's 1/2 of all the way across. So it's also opposite the smallest angle. So here's the smallest angle, and here's the side opposite the smallest angle. We just figured out that it's 9. If this is 9, then the middle side, which is across from the middle angle, the 60-degree angle, is that value 9 times the square root of 3. That's just what it is. Now we have, here's our formula, 1/2 base times height. We now know our base all the way across the triangle is 18. We know that the height is 9 times the square root of 3. We divide that by 2. And what we end up with is 81 times the square root of 3. To finish the problem, we do this 54 pi minus 81 times the square root of 3. You just take this number, 54 times pi, you plug it in your calculator. You then subtract from it 81 times the square root of 3. Whatever the calculator spits out as your answer, that's your answer. The answer in the book is 29.3.